Welcome to the lecture of atomic structure. In this lecture, we are going to discuss what is the structure of atom, then how electrons are organized in atom. So almost all fundamental things regarding atom we are going to discuss here. But the first question is, what is an atom? So we are starting out from beginning and end will be at a deep configuration, electronic configuration. So first question, what is an atom? So atom is defined as it is smallest particle of an element possessing all chemical properties of that element. So from this definition, it is very clear that what is element. So we have to discuss now what is an element. But rather that I should go this way, that how this universe is made up of. So with our present knowledge, say why I am saying our present knowledge, because now scientists are accepting there is tremendous matter, categories of matter that we are not aware. So whatever our knowledge is there, that is hardly 5% about this universe. That is given by scientists. So if scientists are having 5% knowledge, then just consider what I should have that knowledge. And with that knowledge, I am going to teach. So first thing, we are dividing this part, whatever on earth. Let us consider in case of earth. So it is mixture, compound and an element. What is mixture? Mixture can be mixture of any two elements, one element and one compound, or two compound. And like that, probabilities are there. That means more than one component should be there. So it may be 10 mixtures, 10 compounds mixture, 10 elements mixture, anything you can consider. But minimum two components are required. Both components must be either one is element, one is compound. Both may be compound or both may be element. There is no fixed proportion in case of mixing. Say for example, I will take 1 milligram common salt. That is called as sodium chloride. So 1 milligram common salt in 1 liter water. I may take 10 gram common salt in 1 liter water. So whatever the considerations are there, they are considered as mixture. Now from mixture, we can separate out compounds or elements with comparatively easier method. I am using word comparatively. Say for example, I am having salt solution. That is our seawater. So we can take seawater, we can evaporate. On evaporation, water will get lost, and whatever the remaining, they are a mixture of salts, predominantly sodium chloride, but apart from that, magnesium chloride, calcium chloride and variety of salts may be there, depending upon where is the sea and what are the effluents. Then effluent means, say for example, if we are near Mumbai, then chemical zone is there, and a variety of chemicals, they are also entering in the sea. So in traces, this type of chemicals will also get there in the salt. So we can separate out water from salt, comparatively easy method. Now in case of compound, the separation is not that easy. I am not saying easy, it is not that easy. But in case of compound, there is fixed proportion of combining element. Say for example, I am carrying out electrolysis of water. You are aware of the formula H2O. So let me tell you, you will get automatically afterwards knowledge. Just I am giving you example here, therefore I am giving some data. So suppose I am decomposing water by passing electrical current. Then water will give me that whatever the amount, that is give me in the proportion of 1:8, 1 part of hydrogen by weight, 8 part of oxygen by weight. In that ratio, I should get the things. So there is fixed ratio between combining element in case of compounds. But what is an element? So whatever the compounds you can able to separate out. On separation of compound, we have to carry out various method. That is called as decomposition. You are aware of composition, that means to join things together. Decomposition, to make separate. So here we are getting decomposition of the substance. Say for example, just now I told that water, on passing out electrical current, little bit acidified or salty water should be required because conductance should be there. But predominantly on electrolysis of water, we are getting hydrogen and oxygen. This is called as electrical decomposition. Whereas if you are decomposing calcium carbonate, okay, can we carry out one simple exercise? Just I am going to write here. This substance that is called as calcium carbonate. We are going to heat it. This is the symbol of heat. That means we are heating out strongly. Say for example around 600 degrees Celsius if you are heating out. But what is calcium carbonate? From where to obtain? It is limestone. Or even we can consider powder of marble and chalk. Chalk means not present day what chalks are there, dustless chalk etc. they are not there. But naturally occurring part is there, that is called as chalk. So that everything consisting of calcium carbonate. So I am heating out calcium carbonate strongly. I will get here calcium oxide plus carbon dioxide. Now in front of carbon dioxide I have to put here an arrow, upward arrow, that is indicating this is a gas. So this is called as thermal decomposition. Why thermal? Because we are heating out and then substances are getting decomposed. So this decomposition is called as thermal decomposition. Now here this calcium carbonate, that is called as limestone. This is what we are obtaining here, that is called as quicklime. So like that substances are there. Now this is something we are talking about thermal decomposition. So we are having electrical decomposition method, we are having thermal decomposition method. Sometimes we are using a method that is called as chemical decomposition. But it is not actually perfect, but we can consider that. Say for example, iron oxides are there. Generally we can consider Fe2O3, but variety of iron oxides are there. If they are reacting with carbon, then we are getting iron. This reaction is not balanced. I will teach afterwards balancing out. And carbon dioxide is released. So this is actually here we are considering under chemical decomposition. So like that variety of reactions are there. They are there for decomposition. Now when we are decomposing out the substance and finally we are getting something, say for example here I am getting iron. In previous reaction I was getting there either hydrogen or oxygen or both things. So like that things are there. On further decomposition method, that substance should not undergo decomposition. So whatever you are going to carry out on iron, iron will not undergo further decomposition. Therefore, iron is called as an element. Same way, hydrogen is called as an element. Oxygen is called as an element because they are not undergoing further decomposition. So, now part of definition we discuss, that is what is called as an element. The smallest particle of that element possessing all chemical properties of that element, that is called as an atom. But this is all hypothetical concept. In Europe, there was a person named as Democritus. He proposed the theory of atom in Europe. In India, similar theory was discussed in the literature that is called as Vaisheshik Darshan, given by a great person named as Aulukya, but later on he is famous as Cathode. So the concept of atoms, they were there. But again keep in mind, they were hypothetical concept at that time. The real change in this method was carried out by a great scientist that is called as Dalton. Dalton first time given a fantastic data what about atom. But I am always having doubt that he might have confused about Atma in Sanskrit and atom in Greek. or whatever that European language. What is the principle? He says atom is smallest indivisible part of an element possessing all chemical properties of that element. Secondly, one cannot convert atom of one element into atom of other element. Third, one cannot destroy existing atom. Next, one cannot create new atom. So like that principles are given by Dalton. But yet, there was lot of confusion whether atoms are there or not. Because debate was there. And in science, these type of debates are welcome. The literally change was occurred in development of modern physics. Particularly after 1896, whatever the developments are there, they are considered under modern physics development. So now we are focusing in next part about modern physics. In this part, we are going to discuss how pressure is measured. For that purpose, a device is used that is called as barometer. This is made up of mercury. The person who invented this, his name is Torricelli. So we are going to discuss what is now barometer. Now keep in mind, my drawing is not that good, but I will try to draw something. You have to understand it. And secondly, whatever diagrams I am drawing here, they are just schematic diagram. Schematic means for the purpose of study only I am showing. Don't ask me that how tube is standing automatically and all that. So let us start. First, you have to take a tube, which is hard glass tube. Why it is hard glass, I will explain. But right now we have to consider this is hard glass tube. Now this hard glass tube is having length of 1 meter. So you have to take that 1 meter. You are aware 1 meter means 100 centimeter. So here the tube is having length 1 meter, which is filled completely by an element. You are aware of this element. This is called as mercury. Latin name is hydrargyrum. Therefore symbol is Hg. Now this mercury you have to fill till top. In case of mercury, keep in mind there are two types of forces in liquid we are considering. One is called as cohesive forces and other is called as adhesive forces. Adhesive forces means molecules of that liquid is having affinity towards other molecule. Cohesive forces means affinity of same molecule with same molecule. So in case of mercury, cohesive forces are more than adhesive forces. Therefore mercury will come like this, bulging out. Like that mercury will be there. So this is now completely filled with mercury. Now we have to take another dish which is also filled with mercury, little bit. Now I want to invert this tube in this tube. So this way I will invert now tube and I will keep this tube as this way. Now initially I have filled this complete tube with mercury, but now I am making inverted tube. Now what is the expected thing? Because of gravity, all mercury should come down. Mercury is having very high density. Density means mass upon volume. So it is having density more than 13 gram per cc, cubic centimeter. So here mercury will, we are expecting that mercury should go down and a level here should get increased. this way. But practical data shows that it is not happening to 100%. Mercury is going down, but to little bit extent. Say for example, if you are there at sea level, then we will find that mercury will be there something like this. And if you are marking here, this is approximately 76 centimeters. You are aware this total part is 100 centimeter. Out of that, this is 76 centimeter. Mercury is not falling down. Actually, it should, but only this much of portion get vacated out. Whereas here it is there. The thing is that Earth is having tremendous gravitational force. Because of that, Earth is pulling out atmosphere. Atmosphere means gases. They are pulled towards Earth. As a result, the pressure is there, that is called as atmospheric pressure. So here we are getting atmospheric pressure over here. Because of that pressure, mercury is not able to fall down. Little bit it will fall and then equilibrium will establish. Suppose I am going in higher altitude. Sea level is there. Apart from sea level, I will go to higher altitude. Then the thing is that atmospheric pressure will start decreasing out. As a result, if this pressure is decreased, then downward movement is possible. And this way, mercury level will start falling down. So, for approximately every 160 meter altitude, real number is 165 meter, but for general purpose, for calculation purpose, we are considering this as 160 meter. So, for 160 meter altitude, mercury level will fall by 1 mm, 1 millimeter. So here if I am considering this as 760 I should consider this as 760 millimeter. So suppose I am at sea level, it should be 760 mm of mercury. But when I will go 160 meter higher altitude, the level of mercury will fall by 1 mm. Suppose I am going 1600 meter altitude, level of mercury will fall by 10 millimeter. So like that, atmospheric pressure will decrease. So this way, this is the height of mercury column that is measured, and we can measure atmospheric pressure over here. Instrument is called as barometer. The instrument is designed by a person named as Torricelli, and then he told that whatever the thing here, this is vacuum. Why? Because mercury is going down, but mercury is a dense metal. It is in liquid state but metal, very dense metal. As a result, when it is going down, it is not displacing out air. If air is displaced, then barometer will not work. So, there is a vacuum. This vacuum is named as Torricelli's vacuum. So, here we are getting practically creation of vacuum. No doubt it is not up to 100%, but very great vacuum is produced over here, that is called as Torricelli's vacuum. Now, if you are increasing pressure here, then automatically mercury will rise. So, if you are taking this instrument and going under the soil, then obviously under the soil means you have to make tunnel and go downwards. Particularly you are aware of mines and all that. So, if you are going to mines, then you will get idea that pressure is increasing out. So, this way we can measure pressure, that is in terms of millimeter of mercury. So, we are considering 760 mm of mercury. Pressure is written this way, 760 mm of mercury, that is considered as 1 atmospheric pressure. You are aware that as we are going to higher the altitude, pressure will decrease. That's why lot of changes occur. But right now we are just considering here barometer and how pressure is calculated here. So on barometer we are getting pressure in terms of 760 mm of mercury. we are aware of how pressure is measured, that is with help of barometer. Now we have to discuss another like similar concept here, because we are discussing here atomic structure, but we are discussing how pressure is measured, what is element, because this is all things we required here, so we can understand the concept very clearly. Now here we are focusing now on a topic, that is cathode rays experiment. Let us discuss this. In Germany there was a glass blower named as I don't know how to pronounce that, but either Gessler or Gessler, something name is like that. So that Gessler or Gessler, he produced a tube that is called as hard glass tube, having electrodes fitted in it. Okay. Just we discussed barometer. At that time also we used the word hard glass tube. The thing is that atmospheric pressure is very, very high. In our further discussion at some point, not in this lecture, but in another lecture of physics, we are going to discuss what is that great value of atmospheric pressure. But right now I must, it must be very clear that pressure is equivalent to nearly weight of 3 elephants. So suppose hard glass tube, ordinary glass tube is kept, then what will happen? Suppose this is a tube. Atmospheric pressure, that is almost equivalent to 3 elephants. At a time they are pressing down the tube. But it is not breaking. Why it is not breaking? Because there is some opening, and from inside also same pressure is balanced out. But the moment you start evacuating this, evacuating means what? You have to remove air from this. As a result, pressure from here will decrease, and then tube may break. So in order to avoid this rupture, we have to use here hard glass tube, so that can withstand this very, very high pressure. So for that purpose we are using here hard glass tube. Now Gessler or Gessler, he produced hard glass tube. And he provided some good things to this hard glass tube. Again telling this is just schematic diagram. He put electrodes in this tube. At the same time, he was there to make provision here, so we can connect it to evacuation pump and we can evacuate this. So from here we are evacuating, that means what we are doing, removing air from the tube, whereas we placed here 2 electrodes. Let us consider this is as cathode. Cathode means here in this experiment we have to consider cathode as negative electrode, and here positive, because when we discuss electrochemistry, in that chapter we are considering at some stages negative is cathode, anode, and positive is cathode. So like that things are also there. Therefore I am telling you that negative is not always cathode, but in this experiment negative is cathode and positive is anode. So this way electrodes are fed. Now scientists started working on this hard glass tube provided with electrode. You are aware of electricity. If you are having a dry cell, pencil cell, or AAA battery, that something like that, you can check out the EMF or voltage given there is 1.5 volt. You can check out your mobile phone's charger. It is having input voltage, something 230 to 110 volt, like that input voltage, whereas output voltage is 5 volt or plus than that. So like that various voltages we can convert with help of transformer. One type of transformer is called as step down transformer. What is the role of step down transformer? To decrease EMF, to reduce voltage. Say for example your cell phone charger. It reduces voltage from 230 volt to 5 volt or 6 volt depending upon the capacity. So transformer, one type is step down transformer. Other type of transformer is there, that is called a step up transformer, that is there to rise voltage. Now here the voltage rise is expected, so scientists started rising voltage inside this Whereas reducing pressure, you are aware now pressure is measured in terms of 760 mm of mercury. 760 mm of mercury is considered as 1 atmospheric pressure. With help of this evacuation pump, we can connect it to barometer and we can measure pressure inside. Scientists decrease out pressure till almost 10 millimeter of mercury. So atmospheric pressure now decreased to very great, not atmospheric pressure inside the tube, that was decreased to very great extent. That is almost 10 millimeter of mercury, that means 1 centimeter of mercury. And EMF implemented is more. Then they were able to observe some crackling noise in the tube. Later on, they were able to observe some lines of light inside the tube. Then onwards, entire tube was having some sort of glow, color. Then that were fragmented, and like that variety of things. Ultimately, when pressure was in range of 0.1 mm of mercury, see, 0.1 mm of mercury, almost vacuum. And then EMF, that voltage is about 8000 volt. At that time, suddenly there was a darkness in the tube, and then they observed the opposite side of cathode. This is cathode. Opposite side of cathode, the glass start emitting green color light. This is something strange. Light is not produced from inside part. It is produced from glass. And then it is considered as discovery of cathode rays. Cathode is emitting something radiations. Because of that radiations, glass start glowing. Now scientists discovered another substance that is named as zinc sulfide. Don't call sulfate. The name is zinc sulfide. So scientists got the knowledge that if invisible radiations, particularly high energy invisible radiations, they are falling on zinc sulfide, then zinc sulfide start glowing white color, white light. Now substance is there, therefore I am telling important information. Maximum compounds of zinc are white only. Those who are compounds formed directly by zinc, like zinc oxide, zinc chloride, zinc sulfide, always keep in mind zinc compounds are having white color. Technically speaking, we have to say they are colorless. But practically speaking, we are saying it is white. But ultimately, we have to say it is colorless. So zinc sulfide is almost colorless, but we are saying it is white. You might have noticed in old days that tube lights were there, not LED tube light, but having choke, starter, like that tube lights were there. In that tube light, this white color powder is kept, that is zinc sulfide. Whereas invisible radiations, particularly beam of electron and ions, they are getting collided with that screen and it start glowing, giving white color. So you have observed this on. So this is zinc sulfide screen. Now scientists applied zinc sulfide over here. In this portion, they applied zinc sulfide and they realized that this portion is glowing with white light now, not green. They applied zinc sulfide everywhere, but only opposite to the cathode, that portion is glowing. Now they change the location of anode. They place anode here now. This is now anode. They change the direction of anode. Still they observe radiations are going perpendicular to the surface of cathode. That means it was very clear that radiations were emitted by cathode. Presence of anode is important, but direction of anode is not important. You can place anywhere anode here. So this way, first data of cathode rays that we got, that cathode radiations are produced by cathode. They are perpendicular to surface of cathode. Position of anode is not mattering out this. Now some modified tubes were produced. Again I am telling these are all schematic diagram. You can consider this is now something like TV screen. Now here we have placed anode. This is something like TV screen. From front side it is rectangular. So like that tubes are produced where they place here track. Okay, but prior to track, just consider, forget of track. First consider this way. They place here anode, cathode, and they place external electrical field. So this is positively charged, this is negatively charged. Why I am saying here external electric field? The thing is that this is internal electric field. This is placed outside tube, but considerable high voltage is applied. You will find the beam that was going straight line initially, but in application of this electrical field, beam started deviating means change the path towards positive plate. You are aware there is attraction between positive and negative. So here negatively positive, they are getting attracted towards positive. That means cathode rays must possess negative charge. So this is one more information we got. Now just as explained, they place here track. Again and again I am telling, this is all schematic diagram. Don't ask me how track is floating there and all that. And they place here a wheel. Something like this. Wheel is placed here and they started current. You will get the wheel is rotating in this direction. That means cathode rays possess mass, because they are able to implement force. Because of force only motion is there. Without force motion is not possible. You are aware of the formula F equal to mass into acceleration. As a result, force is there, that means there must be mass and acceleration. So cathode rays possess mass. And then based on previous data that how the curve is there and what is the deviation of cathode rays in presence of electrical charge, and then what is the mass of wheel, what is force required to move that, and with what speed it is getting. Scientists were able to calculate a ratio. This ratio that is called as E by M ratio. E stands for charge and M stands for mass. So here we are getting E by M ratio, that is charge to mass ratio. So here we got now ratio, that is charge to mass ratio for cathode rays. So this is all we can describe something about cathode ray. Now we are discussing about a fantastic experiment here carried out by Sir J.J. Thomson, a British physicist. He carried out this experiment. He used different metals as a cathode. I am revising. He used different metals as a cathode here. And every time by using different element as cathode, he calculated charge to mass ratio, that is E by M ratio. And to the surprise, he got ratio as constant. Let me clarify. Suppose we are saying 1 by 2, 5 by 10, 100 by 200, 9 by 18. So variety of values I am considering here. But you are aware, ultimately all value that is ending with 1 by 2. So here 5 ones are 5 twos are. It's 1 by 2. 0, 0, 0, 0 cancel, remaining 1 by 2. 9 ones are 9 twos are 1 by 2. So like that, ratio is constant. So whatever element is there, but it is emitting same type of cathode rays. That means cathode rays must be made up of a material which is there present everywhere. On this assumption, because variety of metals, they are emitting same type of cathode rays. And then he termed that particle as an electron, smallest unit or smallest part of electricity, electrical current, like that. But he named this part as electron. This is the revolutionary concept. This is the first subatomic particle. See, till here, we were not aware that we were having doubt atoms may be there or not there. But now it is sure that subatomic particles, they are discovered, that is, he termed as electrons. But electron is negatively charged. And you are aware that atom is electrically neutral. So, Sir J.J. Thomson said that in order to balance this, there must be equal and opposite positive charge must be present in the atom. And this way, he was able to explain neutrality of that atom. Now, on basis of this, the first atomic model was put forward by Sir J.J. Thomson. He says that there is presence of, must be presence of positive charge. So, he says atom is essentially a sphere of positive charge. Why sphere? So why moon is spherical, why sun is spherical, various stars are spherical, earth is spherical. For a given mass, minimum surface area is available in case of sphere. The most distant particles are equidistant in case of sphere. And therefore, because mass is acting towards center, and therefore atom is essentially a sphere of positive charge. And he says electrons are embedded in between, negatively charged electrons are embedded in between, like seeds in watermelon. And therefore this model is known as watermelon model. So according to Sir J.J. Thomson, atom is an we have to consider it is a sphere of positive charge, and electrons are embedded in between like seeds in watermelon. This model is able to explain electrical neutrality of an atom, but only that. It is not able to explain variety of things like spectra and all these things. Then how positive and negative charge they are together with each other, not explained. So like that, various things are not explained by this model, and therefore this model is discarded. But this is the first model of an atom. Now let us talk of positive charge. We discussed that electrons, they are having negative charge. Electrons were discovered by Sir J.J. Thomson in cathode ray tube experiment. Now same way, there is a scientist named as Goldstein. You can consider, you are aware of Einstein. Similarly, you can consider Goldstein. Goldstein considered atom, as cathode rays are there, there must be anode rays. And he started investigating about anode rays. For that purpose, now he used something different tube. Now here he placed anode something like this. But still, he was not getting presence of anode rays. Then he made some different thing. This is cathode. He made anode as perforated. Perforated means holes were kept in anode. And now, by making holes, he says that whatever the radiations they are emitted, reverse way, he make indication also reverse. So this is cathode which is perforated, anode as it is. And then he says that we have to start cathode rays, EMF we have to increase. We have to make this way, so anode will emit radiation, they will pass through cathode. and surprisingly he got glow in this region, and therefore he says it is discovery of anode rays. Then he applied external magnetic field. In case of external magnetic field, it is proved that anode rays are getting deflected towards negative part, and therefore it is concluded that presence of positive charge in the atom. That positively charged particle is named as proton. This way there was discovery of proton, another subatomic particle. In later on, it was proved that there is no such radiation called as anode rays. Actually, till that he given them as anode rays, then channel rays, canal rays, like that, because channels are made because of this perforated cathode, and so these names are given. But later on proved that no such radiations are there, anode is not emitting any radiation, but you are aware that here we are decreasing out atmospheric pressure to very low, but yet residual gases are there. These gases are getting ionized because of cathode rays, and on ionization the positive charge ions, they get deflected towards negatively charged cathode, and we are getting presence of anode rays. So in wrong experiment, but proof is perfect, that is presence of positive charge that was there. So this way now atom is having electron as well as proton. Two particles are considered here. This is the discovery of anode rays by Goldstein. Presence of protons are proved. But now doubt is there that what is the atomic structure. And then disciple of Sir J.J. Thomson, named as Sir Ernest Rutherford from New Zealand. He was initially from New Zealand, but later on he moved towards England, no doubt British colony only, but he went there and then he studied out and he carried out that experiment that is called as gold foil experiment or alpha particle scattering experiment. On basis of that, he is the person who is able to give atomic structure. Let us discuss in next part. We are discussing about Rutherford's experiment, that is gold foil experiment or alpha particle scattering experiment. Just I will go to schematic, not actual diagram. Actual diagram is something different. But schematically, Rutherford took a gold foil. Gold foil was, according to him, it was very, very thin gold foil. So thin that hardly 4 atoms in thickness, like that gold foil, was taken by Rutherford. Now this is photographic film or photographic plate. This was something drawn like this, and alpha particles are bombarded over this. Now at that time much things were not aware about alpha particle. Alpha particle is essentially positive charge particle. Approximate at that time they considered +2 is charge on alpha particles, and then these alpha particles are bombarded over thin gold foil. What was the expected thing? That gold foil should stop alpha particles. But what result he obtained? They are strange result. Say maximum alpha particles traveled in straight line direction, but few alpha particles got deflected by angle of 30 degree, 60 degree, 90 degree and so on. So like that alpha particles deflected also. Very few, that means 1 out of million, that get deflected by angle of 180 degree also. I don't know how they calculated, but they say that out of 1 million get deflected by 180 degree. On this data, that means actually it was expected that it would stop, but no, they get deflected by various angles and maximum traveled in straight line. On basis of this data, Rutherford says atom is essentially a hollow part. There are two types of space. There should be space between the atoms. He called that as interatomic space. As well as space is there within the atom also. When atom is hollow, then where is the mass of that atom? All mass is concentrated at the center, according to him, because alpha particles are heavy particles. It travels with very high speed, say 3000 km per second. Unaccelerated alpha particle that is having speed somewhere around 3000 km per second to 30,000 km per second. Such a high speed alpha particles are there, but yet no holes are formed here. That means atoms are not displaced. So atoms entire mass should be focused in smaller area, smaller region, that is he called as nucleus. He even measured the size of nucleus. He says that it is 1 lakh times smaller than atomic size. Now, what is the thing? It is essentially made up of positive charge. All positive charge is focused in nucleus. Therefore, he says that if radiations are going like this, they get deflected. Okay? If it is going still closer, it gets deflected with larger angle. And exactly head-on collision, then only back 180 degree. And this way, he concluded the thing. Now, where is the electron? He says electrons are extranuclear electron. Extranuclear means away from nucleus. So they are away from nucleus and they are revolving around nucleus. Like planets are revolving around sun. So that's why this model is called as solar system model of atom, where now sun is at center, here nucleus is at center, here planets are revolving, here electrons are revolving around it. But in case of solar system, the force of attraction is gravitational force. What is the force of attraction here in case of atom? He says electrical force of attraction, positive negative attraction is there. Because of that, electrons are revolving around nucleus. And this way, model was put forward. No doubt, various doubts are here. First doubt, obviously this model is not able to explain spectra. Second, electrons are revolving around nucleus. Nucleus possesses all positive charge, but now Goldstein says that there is presence of proton. If all protons are there together inside nucleus, then why nucleus is breaking out? It should break out. It should split because positive repulsion is there. How nucleus is stable then? Various doubts are there. Then, according to wave mechanics, they say that if charged body is in motion, it should follow, it should emit continuous spectra. It should emit energy continuously and fall down inside nucleus. For that purpose, time required is 10 raised to minus 8 seconds. Keep in mind, this is ultra high-fi minute time. Within 10 raised to minus 8 seconds, all electrons should fall in the nucleus and there should be atomic catastrophe. Touch wood, this is not happening. Why? That means there are some errors in the model and we have to rectify it. Okay. Now let us discuss about the rectification. But prior to that, I must explain, because you might have heard again and again word that J.J. Thomson's atomic model is there, not able to explain spectra. Then we discuss Rutherford's model, not able to explain spectra. So what is the meaning of spectra? We are going to explain. Now we are discussing what is the nature of light, because in order to get knowledge about spectra, we have to discuss this part. So first part here, that is we can say what is nature of light. It is not 100% yet determined. Different theories are there. First theory, that is Newton's corpuscular theory of light or radiation, and second, wave theory of light. So right now we are considering wave theory of light as our basis. They say that light is in form of wave, radiation is in form of wave. Now once I am saying that there is a wave, certain characteristics of these waves we have to consider. So we are first discussing the characteristics of waves. You can see this way. This is positive side, this is negative side, this is the wave. Let us give similar example. If there is a stagnant water, pool of stagnant water, and we are dropping a stone in that water, so you will get concentric rings coming out from that. Concentric rings means having same center, rings will come out. That is called as waves. Then they will go towards periphery, again they will come towards center, like that situation is there. Now add some lighter material on it, say for example piece of thermocol, or say for example a balloon, like that, and then again drop that same stone. You will find that whatever the thermocol piece, that is not going towards periphery and coming towards the center. You will find wave is going towards periphery and coming towards center, but piece of thermocol will oscillate at its original position only. It will move up and down, like that. You might have taken same experience, particularly when boat or launch that is there at you can say that jetty or something like that, and then you can check that every time that wave is coming, that ship is oscillating ups and down. It is not going towards periphery and coming back. It is just oscillating at that particular place. Now here you can check this way, that this is the direction of propagation of wave. That means this is center of pull, this is periphery. Wave is going this way, but particles will oscillate in this is the direction. They will oscillate perpendicular to the direction of propagation of wave. Propagation means in which direction wave is going on. So here the angle is of 90 degree, therefore I am calling it is perpendicular. So this type of waves, they are called as transverse waves. So light radiation, that is a form of transverse waves. So here we are getting these waves as transverse waves, where particles will oscillate in this direction. Now here this is the maximum displacement. Now we are making here a line. This is called as mean position. So original water level was this. After creation of wave, we are getting something upward. This is called as crest. Whereas something going downward, we are calling this as trough. So one crest and one trough will account one wave. So single part of wave is something we have to consider entire crest, entire trough. Maximum displacement, this is the mean position. Maximum displacement from mean position, I can see this is as maximum. Therefore, I am the terminology is that this is minima. But this distance, that is called as amplitude. Amplitude of wave means what? Till what extent wave can go to higher height and lower height, that is the same. So this is called as amplitude. Now wavelength. Now this is one wave I have drawn, but may be possible I may draw this is the wave like that. So how to calculate, how to determine wavelength? Here this is called as mean position. This is also mean position. Mean position. So one wave, consider one crest, one trough. Therefore, distance between alternate mean position, I am saying again, first we have to omit this and second. So distance between alternate mean position is called as wavelength. So first we are determining here wavelength, distance between alternate mean position. Now when we discuss this topic in physics, we are going to discuss somewhat more detail about this, because only this is not the definition. Several other definitions are also there. But right now we can consider distance between alternate mean position, that is wavelength. So wavelength is denoted by a letter. This is called as lambda. Inverted y like something. So this is called as lambda. This is wavelength. Now speed of light we are denoting by letter c. That is speed of light, which is 3 lakh kilometers per second approximately. Real answer something 2.99 etc. But right now we are considering as 3 lakh kilometers per second, that is speed of light. Now frequency, you are aware of wavelength. Another characteristic of this wave, that is called as frequency. Frequency is now this is one wave, or rather I should say one cycle. So number of cycles passing in a second from particular point, they are called as frequency. You are aware of train. Suppose I am standing on the railway station and I want to go to X direction. I will ask what is the frequency of train. It can be given like that. Per hour 20 trains are there. So I will say 20 trains per hour. May be possible 1 train per hour. Yes, that is also frequency. Per unit time, how many trains are there? If I want to go by that through trains are there, long distance train, then it may be there like that 1 train per day. So unit is changed from hour to day. Certain long distance trains, they are twice in a week. So I have to say 2 trains per week. So like that frequency. So here cycle per second. How many cycles per second? 1 cycle per second, that is called as hertz. Because the person worked on this is having name as hertz. So 1 cycle per second is called as hertz. So 1 hertz means 1 cycle per second. So frequency is denoted by letter. This is something called as nu. So now we have frequency that is determined by letter nu. So you are aware wavelength is there. Now here obvious thing is there. I am drawing another wave. If light is there, that means speed is constant of that light. At that time, suppose I am saying this is another wave. Like that. Now here what is increased? Wavelength. So in a second, suppose here 2 waves are passing, red one, 2 waves are passing, but blue one will pass only 1 wave. Here we will get wavelength is more, here wavelength is less. So in case of blue wave, you will find that wavelength is more. In case of this red color mentioned, wavelength is less. Wavelength is less, frequency is more. Wavelength is more, frequency is less. And therefore, we can connect this way that frequency is inversely proportional to wavelength. Wavelength is less means frequency is more. But I have always problem with this type of sign. This is the sign of proportionality. And I want to remove it. How we can remove sign of proportionality? So keep in mind always, when we are removing sign of proportionality, we have to put some constant over there. So nu here I will put sign and put some constant over here, lambda. So actual thing is that I have to apply this way. This is 1 by lambda and multiply by some constant, equality sign and constant, that is substituting out this. So this way we are getting substitution of constant over here. So in short, I am writing this way, that nu, that is equal to some constant into lambda. Now, same way, energy is there. Every radiation is associated with energy. I hope you are aware of microwave oven. A klystron tube is there in the microwave oven that is producing out strong microwave radiations. Microwaves, they are produced and absorbed by water molecule. That's why if aqueous substance is kept in microwave oven, then it is going to get hot quickly. But if water is not there, it will not get heated. Say for example, if you are placing a paper dish and potato on that and keeping in microwave oven, you will find potato is getting hot but paper dish will not. If you are keeping something in glass, then also you will experience same thing, that glass vessel will not remain hot or become hot. But whatever inside material is there, say for example potato or something like that, it is getting heated. So this is something we are talking about, microwave. So here microwave, they are having energy. Sunlight, you are observed, tremendous energy is there. So formula is that energy of radiation is directly proportional to frequency of that radiation. Now you are aware of frequency. So energy equal to, now I have to remove this equality sign and put here some constant. So again I will put some constant and write down this way, energy equal to constant into nu. Now everywhere these constants we are using, and then again and again we using k as constant. Instead of that, some specific constants are there. Let us discuss about these constants. So nu is equal to what we discussed, k by lambda. But you can check out here this relation is true only and only if speed of light is constant. Then only this relation is true. Therefore, we are considering speed of light here as constant. We are aware speed of light is denoted by letter c. So right now I am changing out this k now by c. So nu is equal to c by lambda. Whereas here E is equal to, now this k is replaced by letter h. Theory was put forward by a German scientist named as Max Planck. According to him, light is no doubt in wave but not in continuous form. It is in form of bundles. He says that bundle as quantum, single bundle as quantum, plural as quanta. So light is coming in form of quanta, and each quantum is having energy, that is h nu. H is called as Planck's constant. C is called as speed of light, whereas here h, that is called as Planck's constant. I don't know what is connection between h and Planck's constant, but here consider that h as Planck's constant. Now you are aware nu, that is equal to, here also nu is there. So can I substitute value of nu over here? And answer is yes. So E is equal to h c by lambda. So this way we can correlate energy as well as wavelength. Based on this data, we can now classify radiations. We are aware of radiations, and I will give you here a general idea about radiation, and then we will come to know what is the meaning of spectra. So we will start here about the radiations. I will give here some chart. Now keep in mind, this chart I am arranging this way. This is increasing level of energy. Single axis graph is there, as well as I can say increasing level of frequency. Whereas if this direction I am drawing, I have to write here wavelength. So here we are getting shortest wavelength, here we are getting longest wavelength. Here we are getting greatest energy, here we are getting smallest energy. So like that radiations are there. So first I will write here, okay, this is cosmic radiations. So clear, it is cosmic radiations, but no much things are known about this cosmic radiation. Therefore I have placed here dotted line because some books are mentioning cosmic radiation, some books are not mentioning. But surely known radiation here, that is gamma. Don't get confused with nu and gamma. If at all it's there, then problem of Greek language. Okay, so this is radiation, that is gamma, which is very small wavelength is having, because it is wavelength is small, wavelength is big. So here wavelength is smaller, smallest wavelength is there in range of 0.1 angstrom. What is angstrom? In physics lecture fundamentals we will see that it is 10 raised to minus 10 meter. So even 0.1 angstrom is range of these gamma rays. Then X-rays. Actually variety of groups are there of X-rays, but here right now I am mentioning only superficially, so they are called as X-rays. Then ultraviolet radiations are there, but we are calling them vacuum ultraviolet. Why vacuum ultraviolet? Because their existence is there in ultraviolet radiation, their existence in vacuum. The moment they enter in atmosphere, they get absorbed. Then ultraviolet, then violet. So we can keep in mind sequence this way: vacuum ultraviolet, ultraviolet and violet. Now violet onwards, so I am changing out color here of pen. Violet onwards, the radiations are different, that is Vibgyon. So violet, indigo, blue, green, yellow, orange, red. So this range, that is called as visible range of light. So here we are getting this all visible things here. Only this much spectra is visible. Now red onwards, we are getting here infrared. Then far infrared. Then microwave. Then radio waves. So these all radiations are again invisible. So these radiations are low energy, these radiations are high energy, and these radiations visible radiation. So this is called as spectra. Initially light scattered through prism, that is called as spectra, but now we realize that apart from this visible part, this is high energy invisible radiation, this part is low energy visible radiation. Now it is again and again I want to tell that when we were discussing about J.J. Thomson's atomic model or Rutherford's atomic model, we were telling this way that it is not able to explain spectra. The thing is that every radiation, whatever the wavelength, is associated with energy, and particular element is emitting out particular wavelength only. That is called as characteristic wavelength. Say for example sodium, on heating, one of the spectra of sodium is golden yellow. A few years ago, you are aware that street lamps, they were called as sodium vapor lamp. They are having golden yellow color. Now that is replaced by LED. But some 4 or 5 years ago, these lamps were made up of sodium vapor lamp, and maybe possible some of the cities might have continued that sodium vapor lamp use also. So that sodium vapor lamp that is having golden yellow color, that is characteristic wavelength of sodium. That's why if you observe from distance, say for example we are there in Mumbai, so when we are crossing out creek, at that time we were observing distant series of these lamps. All lamps are having same shade of golden yellow. It is not something is having pinkish, something is having reddish, like that. No, everywhere the shade is same. So that is called as characteristic spectra of that particular element. So why particular element emits only particular wavelength? Say for example, if potassium is there, potassium will emit lilac color. Calcium is there, it will emit apple green color. So why particular element emits particular color only? So this is not explained on basis of J.J. Thomson's atomic model as well as Rutherford's atomic model. And that's why we have to consider that the spectra is not explained on basis of this model. And to overcome this all, a new model was put forward that is called as Bohr's atomic model. Now henceforth our study will go in much more detail. So let us consider now Bohr's model in next lecture.